Hello, everyone. So my name is Jakub Wabiński, and I represent the local university here. And together with my colleagues, we did 2 pieces of research on tactile maps, and I'm going to talk about one of them. And in considering the number of people in the room, you got scared of the word standardization. I will do my best to make it interesting. Right, just a brief introduction of our tactile maps. Just no mystery. These are just maps for people with visual impairments that contain most usually haptic content for touch perception and the graphic content for visual perception. And the main idea, the presentation will be from my perspective, from cartographic perspective. So it's going to be a bit different, I suppose. But the main issue in tactile mapping is simplification or generalization, how we call it in cartography, because due to the limitations of tactile perception, they have to be greatly simplified, right? Yeah, that's a slide that I have that is usually directed to the cartographic audience, right? That they are not aware how many people with visual impairment there are in the world. But just one nice example, I think, is that according to World Health Organization, it is said that there are 36 million legally blind in the world. That's the population of Poland, roughly. So yeah, it's not a niche topic. But getting back to the to the thing that I said about the issue of simplification, that it has to be way more. Tactile maps have to be way simpler in comparison to classic maps. And this derives from the fact that the resolution of a finger is approximately 10 times worse than this of an eye. And on the slide here, there are just examples. How is this resolution explained? So resolution of a finger or of an eye is the ability to distinguish 2 points as separate, like the minimum distance between them that has to be maintained so that they are distinguished. So yeah, so the resolution of a finger is 10 times worse, which means that we have to make tactile maps that are either 10 times simpler or 10 times bigger, right? It's not possible to make them 10 times bigger, since using a map that is, I don't know, 2 by 3 meters in size wouldn't be really handy, right? So we have to simplify it. And then on the slide, here's a comparison of different recommendations about sizes of symbols, in this case, a circle. And the one on the left, oh, these are not in scale, obviously, but what I wanted to show is the ratio, like between the minimum size of a symbol, a circle in this case, right? And then on the left, classic example from topographic maps, and then the recommendations about the least recommendations in terms of sizes that I found, right? So you can see there's a decent difference. And then again, how it looks in a case study. There's a map of the world of landscapes, and you can see a classic map on the left, and then tactile map equivalent on the right. Right? You can easily see how simplified it is. And okay, that's a challenge already, right? If you want to make tactile maps, so you have to simplify them and think how to do it, right? But then another issue is that in classic cartography, you use something called graphic variables. And okay, sorry, the slide is in Polish. I didn't realize. Anyway, okay, so one of the most suggestive graphic variable is color. And you can't really use it on tactile maps and like apply to the haptic content, to the tactile content, right? You have to use haptic variables instead, such as shape, texture, orientation, resistance, like size, height, and so on, right? Some of them are common, like graphic variables of size. It exists as well, but some are very specific. One of them is the height of the symbol, right? That is not used really in classic cartography. And so if you consider the recommendations in classic cartography, it is usually sufficient to differentiate symbols using only one variable. Say, for example, color, right? Unless you have some color vision disorder, you're okay to differentiate these two symbols. But in tactile cartography, you have to use at least 2 or preferably 3 variables to differentiate symbols. In this case, shape, size, and type of fill or sort of an outline, depends on how you call it. Okay. So with this brief introduction, I just wanted to say it's pretty complicated to make tactile maps, especially if you want to transcribe the existing tactile maps, the existing maps, instead of creating new ones from scratch, which is a common thing. And in order to make this process of transcribing classic maps into tactile form and make them legible, it would be a good idea to standardize the process, right? So currently, tactile maps production is expensive, is time-consuming, requires involvement of a team of specialists, and by standardizing this process, tactile maps can be produced, or I believe they can be produced faster, cheaper, in a repetitive manner, and according to users' requirements. Well, you know, it's like tactile maps are usually made according to the users' requirements, to the tactile to the target group requirements. But you can do this in an automatic way, standardizing the process. So, so the ultimate goal of, say, my research is to develop tactile maps automatically that are legible, that are useful, that are comfortable to use using open spatial data, right? So why are maps being made from scratch using graphic software instead of using open spatial data that we have available online for free? And we can just convert this data, generalize it, simplify it, arrange it in a specific way, and then generate maps on demand. Yeah, using automatic generalization algorithms, that's a bit technical. But what I mean here, if we standardize the process, if we name specific parameters, we can then throw these parameters inside algorithms and they will handle the job for us, right? Instead of doing the manual job, we can automate this process. What else that we need for this are the unequivocal reduction rules and generalization parameters. So if we want to automate the process, we need specific parameters that we can tweak. And if we have the algorithms, we have the pipelines, we can just adjust them to make maps that we need. So there are solutions that are using open spatial data and that generate models that are ready to be 3D printed, for example, but they don't really consider any type of generalization. This is one of the examples. You can look at them online. As far as I remember, this one is from tactilemaps.net. You just select an area and you get an STL 3D model format that you can throw in 3D printer and just print it. But you should ask yourself the question if the map on the right will be legible using Touch. All right. So what's the status quo now? The thing is that in classic cartography we have some conventions that we don't really have in tactile cartography. For example, water is blue, forest is green, right? And this is just an example of the area we are at. It comes from the official topographic database in Poland, data in vector format, and you can just use them to print maps and so on, right? And then, yeah, forest, like green areas are green, which makes sense, and then water is blue. And when it comes to tactile maps, well, that's not the case. So yeah, that was a pretty long introduction to what we did and our findings in this case. So the goal was to look for the literature, for the research papers, but mainly for best practices of creating tactile maps across the world, right? So you know, like research papers are pretty easy to find because they are usually published in English. They are usually indexed in different databases. So yeah, these are pretty easy to find. And we browse over 500 sources from the last decade using systematic and critical literature reviews. But what we wanted the most to find were the best practices that are usually not published, or maybe they are published, but only locally in local languages. And for that, we prepared a questionnaire that we have disseminated among the members of the Commission of Maps for the Blind and Visually Impaired of the International Cartographic Association. And we got only 8 responses. That's not a lot, but from the 7 different countries, and the responses were really meaningful. And then again, critical literature review, but not browsing the actual scientific databases, but internet in general. That was a tough work. And I already know that we haven't included, obviously not all of the guidelines that are used across the world. I just came across the ones from Indonesia a couple days ago. So yeah, I know that there are more, but this is what we got. So in terms of standardization, what were the previous attempts? So one of the earliest ones that I encountered is something called the Nottingham Kit that was then expanded to Eurotown Kit, and it was supposed to propose a set of symbols for urban areas with their corresponding meanings. And the production methods were rather manual, right? Then there are 3 ISO norms that are somehow related with tactile graphics and tactile maps, and one of them is 19028. But it's very technical. There are some parameters, but if you look at the appendices, you get Japanese examples of tactile maps, tactile marks, Swedish examples of tactile marks. Nobody says, right, this is the right way to do it. This is the only way to do it. It's an ISO norm. You would expect them to tell you, okay, this is the standard, right? Just follow it. No, they just give some examples. And that's basically it when it comes to standards, the official standards. Other ones that we found, and I'm just showing you some examples, are more like guidelines. For example, guidelines from Australia that provide some verified symbol designs, verified redaction rules. But for example, in this case, they provide you with a set of symbols that you can use on tactile maps, but they don't tell you what production technique to use. Then that doesn't really make sense, right? Because different production techniques require different approach. Another example, and in this case, they explicitly say that the, for example, the textures that you can see on the slide, the recommended textures and how to combine them on tactile maps. And they say, okay, these are to be used with swell paper, which is okay in this case, right? And then they give some parameters, say the space between point, symbol, and any other component must be minimum 3 millimeters, and parameters like that. And then we also, and the ones that I'm presenting now, they come from the United States and Canada combined, and they also provide some examples on how to transcribe classic map into a tactile map. In this case, average precipitation in Australia, and you can see that there are 12 categories, I believe, on the classic map that are being converted to only 4 on tactile map. So this is a simplification that I was talking about. But they give some nice examples on how to do it, right? Instead of making a map from scratch. And then also standards that are Polish standards, and they are called standards, but they are just recommendations again. And these are published in Polish, for example. So I was aware of them, but people from abroad probably are not. And there's a cool example because they propose this system of abbreviations of geographic features, 3-letter codes that the first letter, the Braille letter, denotes a type of a feature. Say an ocean, that's a Braille O. Sea is a Braille M. In Polish, it's morze. But there is a cool, another cool example that I want to talk about now that I encountered when browsing the literature. Say in this Polish standards, they say, okay, if you depict water bodies and you want to use a texture, then you use horizontal lines. Okay, that makes sense. And every person with visual impairment in Poland is used to this convention. This is sort of a convention. But the problem is that you can find the same, but not really the same ideas in other guidelines. Say in the United States, they say, okay, if you depict water bodies, you use waves instead of horizontal lines. And in Australia, you use slanted lines, you know, angled. And this is something what I call local standardization, which is okay. But if a person from Poland goes to the United States, and they use these horizontal lines for something different, and they will think, okay, there's a water body. I should avoid this area, maybe without referring to the legend, right? Okay, but these were just examples of the guidelines that I went through, and we summed up all of the parameters that we found, recommended symbols in the paper that I will show at the very end. But what interested us the most were the questionnaire results. So the previous ones were easy to find online, apart from the example from Poland, because you probably wouldn't find it without knowing Polish language. But we have conducted this questionnaire, right? And we got responses from Brazil, Canada, Iraq, Mexico, Poland, UK, and US. So the questionnaire was like, it consisted of a number of questions. For example, the most important one was, do you have any guidelines in your country that you follow? Okay, and if so, please provide a resource. Then others were more specific. For example, how many textures is it allowed to put on a single map sheet in your country? Or do you use height differentiation of sign? Or what production techniques do you use? Yeah, and we got many useful locally applied best practices that way, because from these 7 different countries, we got the actual best practices, or maybe six examples in their local languages, right? So we got the one in Portuguese, the one in Spanish that you wouldn't find otherwise, probably. Right? We need to translate them then, but it is okay. So again, in case of some responses, when we asked about specific parameters, they provided us with very specific numbers, whereas others just commented on, oh, okay, it depends on the context, which suggests that perhaps some of them, they follow specific rules, whereas others, they do it manually and they just adapt it depending on the context. And it was funny to see that there was no agreement in most cases about the parameters used. For example, when we asked about the maximum number of textures to be used on a single map sheet, the answers ranged from 2 to 20. But I believe the 20 was somebody had just misunderstood what I asked for. But anyway, other responses were from 2 to 6 maximum textures. Yeah, the one very constant answer was when we asked about the formats, they use something in between A4 and A3, which are, they would call it the B formats that are being used in the US, for example. But that, yeah, but the sizes are more or less within this span. And it was interesting to see that only 25% of the responses actually use different height differentiation of tactile signs. So signs are being put on different heights, which, if we look at the literature, is being said to be a very important way to facilitate reading of tactile maps. Right, and this is just a graph of the production techniques that the respondents use, and it is also interesting to see that two things, that handcrafted tactile maps are still very popular, whereas 3D printing was mentioned only by 2 of the respondents, which is interesting if we consider how many 3D printed materials we saw during this conference. That it's just being used in almost every application, and it can be used in tactile map printing as well. Right, and in terms of the results of the review, the paper is filled with this kind of tables that you can find specific parameters about specific characteristics, say the minimum distance between different symbols, meaning different symbols of different categories. And the answers range from 1 to 5 millimeter. The 1 millimeter value is the one from the research that we have conducted. In certain conditions, it is possible to reduce the distances to 1 millimeter and still maintain legibility of the map. One of the requirements is that the signs are being put on different heights. And apart from that, we have gathered all of the symbol recommendations, and where it was possible, we quoted the production methods that were used along with the symbols. But the problem was that usually they were not quoted, right? Right, getting into conclusions. So, from the review itself, selected aspects of tactile mapping can be easily standardized. And there was a follow-up research to this one that we have done, in which we used this generalization algorithm, open spatial data, and semi-automatically, and I will introduce it explain in a while, semi-automatically produced a hybrid tactile map using 3D printing with graphic content and tactile content. And then we tested in the School of Lasky, and it turned out to be legible and useful. And we only did some manual editing of, for example, label placement of 2 or 3 features, and then applied some colors and stuff like that. But other than that, the process was fully automatic. The generalization process was fully automatic. But that was possible because we created the algorithms and we fed them with the parameters that we got from this review. Official bodies usually issue high quality tactile maps, but they're very expensive at the same time because they use manual approaches, most cases. In Poland, the head office of geodesy and cartography is the one that is issuing atlases. They're of really high quality, they are widely accepted, but they issue them only once in a while. And if you weren't lucky enough to get one of the copies, then you probably won't get it later, right? Because they are not repeating the production processes. Whereas maps being produced automatically usually are not appropriately adapted, right? The case of the system that I was showing you, right? They use open spatial data, in an automatic way. Result is being produced, but they might not be useful, and it's usually easier, at least from my perspective, if these are just navigation aids, because they don't have to be that detailed. But when you produce thematic maps, you want them to be true, right? Real. I mean, in navigation as well. And then most useful and explicit rules usually come from the less official guidelines. So from the best practices that we obtained by conducting the questionnaire, and you won't find them in research papers usually. So it's something called gray literature. You have to look for it if you want to obtain some interesting parameters. And the very most important conclusion is that if you look at the parameters quoted in the paper or whatever, or you look through the guidelines, you always have to consider them only as inspiration of approximate values that you have to tweak yourself when making maps. It would be best if you just do it with experiments with people with visual impairments in iterative experiments. But this is a starting point, right? You can get them and you can use them, as a starting point. And then combining these automated workflows, this automated generalization with modern production techniques that allow unlimited or almost unlimited production of symbols, because we are aware of the limitations that, for example, Braille embossers or swell paper have in terms of science design. There are some other techniques that allow production of different shapes. Just for example, 3D printing. It has other disadvantages, of course, but yeah, in terms of what we can produce, is a really good technique. Then mixing this with the parameterized design rules, reduction, and generalization. All these combined can result in an automatic workflows and wider access to legible tactile maps, which in turn will result in their greater availability, which should be our goal. Okay, and just to sum up, Emilia is going to be talking about other research. This is a set of 52 symbols with their corresponding meanings that we now developed, and we have all the specific parameters for every of these symbols that were verified in 2 iterations of tests that Emilia will talk about, using DLP or resin 3D printing. So this is somehow our input to that, what I'm talking about, but this is something more recent than the previous research. Then you won't find these symbols in this paper, right? So if you're interested, you can just you can scan it, you can just write down, and it's in open access, so you can look at it. And and if you have any questions, I would be happy to answer them. Thank you.